Now let's look at some of the softer concepts of parallel computing: threads, processes, and the operating system. So what we're going to assume here in this course here is that we have some shared memory hardware support. There are some multi-cores without shared memory also. That's more or less a different course. I might bring it up when we talk about architecture later on. But we are assuming a shared memory hardware support. So we have the individual cores here, and they have access to a shared memory. And then we have an operating system that can provide processes with individual address spaces. So you have multiple processes here. And you have then threads. So each process then can create individual threads that share address space within a process. So the memory here, which the cores share, that's the physical memory. The memory address space that processes use is a virtual memory address space. And each process has its own virtual address space that is not in most cases not overlapping with any of another process virtual memory space. So even though the physical memory is shared, processes do not share memory. But the threads within a process, they do share memory. So the operating system's task here is to not only provide the virtual memory address spaces for each process, but it will also provide a scheduling mechanisms to schedule the threads onto the available cores. And of course, it's when you have multiple processes, you also, of course, then have take the risk that the OS will schedule threads from different processes simultaneously. There is sort of no guarantee in modern operating systems like Linux or Windows or Solaris that the threads from the same process will execute simultaneously. For parallel computing, you really would like that to happen. So as a first order of approximation, if you want to execute a parallel program and you want to sort of measure the performance and so on, you would like to be the only sort of process that is executing at any given time. Then the OS will take the threads off that process and schedule them onto the threads. This is an active area of research for operating systems. How can several simultaneously executing processes or programs sort of share the multi-core, the parallel machine, so that each process gets a fair use of it and without overcommitting the hardware resources. It might be worthwhile also to ponder on what is a thread anyway. So the process consists of user address space and at least one thread of execution. And typically the address space is divided into various segments. You have the segment's text, which contains the instructions, the functions that build up the program. You have data, which is sort of statically allocated global data in the program. And you have a stack. And the stack will contain dynamically allocated variables and also state when it comes to you build up state when it comes to the execution of nested functions, so that you can go back, find the way back when you execute a subroutine. And then finally you have the heap, which is the storage space for dynamically allocated data. And the process has an ID, it has a group ID, and it has belongs to a user ID, and the process owns any open files, any kind of locks and sockets that you're using. In a process, as we have seen before, you can create new threads of execution. What that amounts to is that it will lead to that a new stack is allocated for each thread of execution. So the stack also provides a storage space. Well, we have the stack pointer for each thread, and then a storage space for the program counter and the registers for a particular thread. So each thread has this state which consists of a copy of all the registers that it occupies in the processor. So threads may or may not execute simultaneously if you have a multi-core processor. If you have a sequential serial processor with a single core, of course they cannot execute at the same time. So the operating system will take turn in scheduling threads on the processor. You have time sharing. But with a multi-core processor, the threads of a process may and hopefully will execute simultaneously.